Hello everyone, this is Dr. B.M. Rao from School of Technology, Githam University, Hyderabad, teaching the course Fundamentals of Digital Logic Circuits for second year BTech students. Welcome to this very first lecture on digital concepts. In this lecture, we are going to review the basic digital concepts such as digital versus analog quantities, bits and logic levels, and digital waveform parameters. To understand the working of digital systems, it is important to know how digital quantities are different from analog quantities. As depicted in this diagram, analog quantities have continuous values. This means that the quantity is defined for every instant of time. Digital quantities, on the other hand, have discrete sets of values, which means the quantity is defined only for certain discrete intervals of time. Analog waveform more realistically represent physical quantities such as sound, temperature, etc. Digital waveform approximate real values if there are many discrete levels. In an ideal case, a digital waveform represents an analog quantity only if there are infinite number of discrete levels. We are all familiar with the conventional number system which use 10 digits from 0 to 9. This system is called decimal system. For digital systems, binary number system is more appropriate. This system just use 2 digits 0 and 1. Binary digits are also often expressed as low and high levels. In a digital system, binary values are represented by different voltage levels. The figure depicts two types of digital pulses representing binary values, that is positive going pulse and negative going pulse. For a positive going pulse, the transition representing low to high is called as rising edge or leading edge. Similarly, the transition representing high to low is called as falling edge or trailing edge. For a negative going pulse, the transition representing high to low is called as falling edge or leading edge, and the transition representing low to high is called as rising edge or trailing edge. Major parts of a digital pulse to be familiarized with are baseline, amplitude, rise time, fall time, and pulse width. Baseline is the lowest level of the signal. Baseline is the lowest level of the signal, and amplitude is the difference between baseline and the peak of the signal. Rise time is the duration of time for which the signal amplitude rises from 10% to 90%. Similarly, the fall time is the time duration for which the amplitude reduces from 90% to 10%. Pulse width is typically defined for a digital waveform from 50% of the amplitude on the leading edge to the 50% of the amplitude on the trailing edge. For a digital waveform, this diagram represents the pulse width and time period. This is basically a rectangular pulse where the pulse width T subscript W and the time period capital T are clearly indicated. We know that pulse width is measured in seconds. Time period is also measured in seconds. Frequency for a digital waveform is defined as inverse of the time period. It is measured in hertz. Duty cycle is another important parameter for a digital waveform. It is often expressed in percentage as the ratio of pulse width to time period multiplied by 100. Topics discussed in this lecture include digital and analog signals, binary digits and logic levels, and digital waveform parameters. Thank you for watching.